Okay, we're going to move on and do part 3 of the section dealing with the sum and difference identities. And these formulas should be memorized by now, but I know you have the purple paper in front of you, so I'm going to keep mine right in front of me. I might need it. These are in your notes, and you should have all these already copied. Write them down somewhere. You do not have to print out the notes, but you should have them with you. We're going to prove this identity, that the sine of pi over 2 minus x is equal to cosine. And this this minus, this difference, I'm going to be able to expand using that formula. So looking at that purple paper, it is sine of A minus B. Sine A cosine B minus cosine A sine B. And I just used my formula and I know some of these values. I know that the sine of pi over 2 is 1. I know that the cosine of pi over 2 is 0. And because this is 0 times x, or 0 times the sine of x, all this will be 0. So what I have left is 1 times cosine, which is equal to cosine of x. It is a proof. It is an identity. On part B, tangent of A minus B. So again, I'm going to use my formula. Tangent of a minus should be tangent of A minus tangent of B. Divide that by 1 plus tangent of A times tangent of B. And I am using the formulas, the purple paper, so use the purple paper. And then I need to calculate this one, the tangent of pi. You can look at the tangent graph. The tangent of graph at pi, the tangent is 0. So you have tangent of x minus 0. In the denominator, you have tangent of x times tangent of pi, which is 0. So you simplify a little bit. I am multiplying by 0, so this is 0. 1 plus 0 is a 1. And in my numerator, all I have is tan of x. And yes, tangent of x is equal to tangent of x. It's a proof, it is an identity, it is true. All right, one more. Cosine of a difference, cosine of 2 pi minus x, and that should equal to cosine of x. Again, use the formula. The cosine of 2 pi minus x should be cosine 2 pi cosine of x plus sine of 2 pi sine of x. And then doing a little bit of algebra, the cosine of 2 pi, I could look at the cosine graph and know that's 1. Look at the sine graph and know that the sine of 2 pi is 0. And because 0 times anything will be 0, I have cosine of x equal to cosine of x. So that's another proof. It's an identity. It is true. Now, for example, number 5, it has already worked out. I just want to talk through it. You're given, that is the original problem, cosine of this sum, and then cosine of that minus. I have to add those two together and then set that equal to 1/2. And I'm going to solve in that interval. So I'm going to just talk through it. This is a cosine of a plus a plus b, and that is this part right there. Look at it, make sure you agree. Use the formula sheet. Cosine of A, cosine of B, minus sine of A, sine of B. And then this is the minus, and that's all this mess over here. Ooh, the highlighter kind of looks off, but okay. After doing all that, I can calculate what the cosine of pi over 3 is and the sine of pi over 3. I could calculate some of those values, and that's what I did here. So the cosine of pi over 3 is a half. The sine of pi over 3 is about 3 over 2. And I calculated these values. And then I can combine like terms. I do have this minus, this negative, and that's positive. So those go away. That's 0. I could add those together. And that's just going to give me one cosine. And if I have the cosine of x equal to 1/2, remember that the cosine is positive in quadrant 1 or quadrant 4. Draw a triangle. You're going to get pi over 3 in quadrant 1. You're going to get 5 pi over 3 in quadrant 4. More homework. Okay. If you have any questions, let me know, and we'll talk soon.